Welcome student to online classes of mathematics for class 9. In this video we are going to study chapter number 6, which is lines and angles of NCERT textbook, and we will be covering exercise 6.3. This is session number 4 for this particular chapter. Myself Deepak Gautam, TGT Mathematics in Kendriya Vidyalaya Sangathan. So let's start with today's class. The topic that we are going to study today is the angles and property of a triangle. Okay, this is explained by the theorem 6.7. The statement of this theorem is the sum of the angles of a triangle is 180 degree. This is something that you have been studying from previous classes. Okay, you have already know that the sum of the angles of a triangle is 180 degree. Okay, here we are going to prove this theorem that the sum of the triangle, all the angle of a triangle is 180 degree. Okay, so first we start with the given part. We will write, given is a triangle PQR. We have taken this triangle which is PQR, this one, in which angle 1, angle 2, angle 3 are the angles of triangle PQR. We are having three angles. This is angle 1, angle 2 and angle 3. Okay, these are the three angles of triangle PQR. We need to prove that the sum of angle 1 plus angle 2 plus angle 3 is equals to 180 degree. Okay, so this is what we are given. We are given that we have a triangle PQR in which angle 1, angle 2 and angle 3 are the angles of triangle PQR, and we need to prove that sum of the angle 1 plus 2 and plus 3 is equals to 180 degree. So we are going to start with the construction. We will construct a line. Construction is, draw a line, let's say AB parallel to the line QR. Okay, so we are going to draw a line which will be parallel to QR, and let's write passing through point P. Okay, that means we have to draw a line like this which has to be parallel to the baseline QR, and it should pass through PQ. Okay, let's name it A and B. Okay, so this will also make two angles here. So one angle here and another angle on this side. Let's name this angle as angle 4 and angle 5. Okay, so by construction we have drawn that they draw a line AB which is parallel to the line QR and passing through point P. Okay, so now we are going to start its proof. Its proof is very simple. We are going to use the theorem that we have studied in the previous session, which was, if a transversal intersect two parallel lines, then the alternate interior angles are equal. Okay, that is the theorem 6.2. It says if a transversal intersect two parallel lines, then the alternate interior angles are equal. So from figure you will have that the line AB is parallel to QR. So I'll write, since AB is parallel to QR and we are taking this side as the transversal, and PQ is a transversal, therefore the angle 4 will be equals to angle 2 because they are alternate interior angles. Okay, they are alternate interior angle 4, this angle will be equals to angle 2 because they are alternate interior angle between parallel lines AB and QR, and PQ is a transversal. So let's name this equation as equation 1. Now moving ahead, now we'll take these parallel lines again, AB parallel to QR, and we'll take this transversal. In that case the angle 5 and angle 3 will be equal again because they are alternate interior angle. Okay, so I'm going to write that here, since AB is parallel to PQ and this side PR is a transversal and PR is a transversal, therefore angle 5 will be equals to angle 3. let's name it equation number 2, and the reason for this one is again why they are equal, because they are alternate interior angles. Okay, they are equal because they are alternate interior angle. And on this point P, you will find that we have three angles, that is angle 4, angle 1 and angle 5, and all the point angles are at the point P. So as we know, the sum of all the points, sum of all the, not points, all the angles at a point is 180 degree. In previous class you have studied that in class 7 that the sum of all the angles at a point will be 180 degrees. So we are going to use this statement, so that will be, therefore the sum of the angle 4 plus 1 plus 5 has to be equal to 180 degree. Therefore the sum of angle 4 plus angle 1 plus angle 5 will be equals to 180 degree, because all of them are the angle at the same point, okay, which is P. So let's name it equation number 3. Now we'll write, now using equation 1 and equation 2 in equation 3, we'll use this equation 1 and equation 2 in this equation 3. So we'll write, we get, okay, what we're gonna get is, at the place of this angle 4 we can write, because this 4 is equals to angle 2, so at the place of angle 4 we can write angle 2, and here we have already angle 1, and at the place of this angle 5 we can write this 5 is equals to 3, so at the place of angle 5 we can write angle 3, and on the other side we have equals to 180 degree, or we can rearrange this as angle 1 plus angle 2 plus angle 3 will be equals to 180 degree, and this is what we are asked to prove here, that angle 1 plus angle 2 plus angle 3 is equals to 180 degree. Okay, this is what we were asked to prove here. So that's the proof of the theorem 6.7. okay, now moving ahead to the next theorem, we have theorem 6.8. It says, if a side of a triangle is produced, then the exterior angle so formed is equal to the sum of the interior opposite angles. Okay, if a side of a triangle is produced, then the exterior angle so formed is equals to the sum of the let's write two interior angles, sum of the two interior opposite angles. Okay, which means, suppose we have a triangle, let's draw a triangle. Suppose we have a triangle like this. Let's name it A, B and C. Okay, now in this triangle, this theorem says, if one side of a triangle is produced means extent. So we are producing this side BC to a point, starting from point B we are producing it in the direction of C till a point, let's say D. Okay, so we have produced means extended, we have extended the line BC starting from B toward the direction of C till a point D. Okay, so this will form an exterior angle, that angle will be here, this is exterior angle, which is formed by when we extend the one side of this triangle, that is side BC is extended till point D. Then the sum of this angle will be equals to the sum of two interior opposite angle. The interior opposite angle to this angle is angle A and angle B. Okay, that means if you add the measure of angle A and B, you will get that equals to the exterior angle. Okay, so we'll write that is that is the angle ACB, which is the exterior angle, will be equals to angle A, or we can write angle A plus angle B. Okay, this is exterior angle ACB. Angle A can be written as angle BAC, or an angle B can be written as angle ABC. That's what this theorem 6.8 says, that if one side of a triangle is produced, then the exterior angles of formed is equal to the sum of the two interior opposite angles. Okay, that means the exterior angle, which is this one, angle ACB here, will be equals to the sum of angle BAC, this angle, plus angle ABC, this angle. Okay, that's what this theorem says. This theorem is also generally called exterior angle theorem. Okay, in general word, this theorem is called exterior angle theorems. Okay, so whenever we are going to use this theorem, in the bracket we have to write that using exterior angle theorem. Okay, this theorem 6.8 is commonly called as exterior angle theorem. Okay, now based on this we have the exercise 6.3. Now let's move to the exercise 6.3. we have here this exercise total have 6 questions, so we are going to do all the question one by one. First question here is, in figure 6.39, side QP and RQ of triangle PQR are produced to point S and T. So the side PQ and RQ are produced to side S, to a point S and T respectively. Okay, so we have this side, these two sides are produced till point S and T. Okay, such that if angle SPR is 135 degree, this angle SPR, this angle is 135 degree, and PQT is 110 degree, this angle PQT is 110 degree. We have to find one angle, which is angle PRQ. We have to find angle PRQ, this angle. Okay, so we'll start. First we'll write the given part and to find part. Let's write answer number 1. Okay, first we'll write given. Given here is a triangle PQR in which the sides QP and RQ are produced to points S and T respectively. Okay, this is what given to us. Now we have to find that the measure of angle PRQ. We have to find the measure of angle PRQ. So let's start its proof or solution. Okay, now you will see in the figure we have this angle 135, which is the exterior angle when the side QP is produced to point T. So this is the exterior angle. Similarly, the side QR is produced till point T, then this is also another exterior angle. Okay, so we can solve this question in two ways. First is by applying the exterior angle theorem or the angle sum property. Okay, for that we need to find these two angles. Okay, so let's write this answer. All right, we have angle QPR plus angle SPR equals to 180 degree. Okay, this angle QPR plus angle SPQ So let's start the solution. We have these two angles. Let's write their name: angle QPR and angle SPR. That is angle QPR plus angle SPR equals to 180 degree. Okay, why they are 180 degree? Because they are forming linear pair. So in the bracket write linear pairs. Okay, and we are given the measure of angle SPR is given as 135 degree. So we have angle QPR plus angle SPR is given, which is 135 degree equals to 180 degree. So from here the measure of angle QPR will be 180 degree minus 135 degree. So the angle QPR will be equals to 180 minus 135 will give us 45 degree. So the measurement of this angle is 45. Okay, in similar way you can find the angle this one, angle PQR. Okay, so we'll write similarly the angle, the given angle is PQT, angle PQT plus angle PQR. Angle PQR is equals to 180 degree. Again they are linear pair. Linear pair means two angles on a line at a same point. Okay, angle PQT is given, which is 110 degree. So at the place of PQT we write 110 degree plus angle PQR equals to 180 degree. Okay, so from here angle PQR will be 180 degree minus 110 degree. So angle PQR will be 180 minus 101, sorry 110, it will be 70 degree. So we got measure of two angle of triangle PQR. So this angle is 45 and this one is 70 degree. Okay, now we can easily find the third one by applying the angle sum property. Okay, now in triangle PQR, the sum of angle PQR plus angle QPR plus angle PRQ, okay, will be equals to 180 degree, and this is by the theorem 6.7, which is angle sum property of a triangle. Simply we'll write angle sum property. Okay, angle sum property of triangle. So we have value of PQR, which is 70 degree, and angle QPR is 45 degree, and angle PRQ we have to find, which is equals to 180 degree. So the angle PRQ will be equals to 180 degree minus, when you add these two angles, 70 plus 45, this will be 115. So 180 minus 150 will be 65 degree. So this measure of angle PRQ is 65 degree. So that's the answer of question number 1 of exercise 6.3. I hope you have understood it. This is very easy question. Okay, now moving to the next one, we have in figure 10.40, angle X is 62 degree, angle XYZ is 54 degree. If YO and ZO are the bisector of angle XYZ and XZY respectively of triangle XYZ, we have to find two angle. One is OZY, this one OZY, this only this part, and I'm going to mark that with the red ink. We have to find this angle OZY and the angle YOZ, this one YOZ. So we have to find these two angles. Okay, while we are given the measure of two angles. So let's write the answer number 2. First we will mention the given part. given here is a triangle xyz. So when you write the given parts, you will always first write the name of the figure in which we are dealing. So here we are dealing in the figure xyz. So right, given is a triangle xyz, then comma, in which angle x is equal to 62 degree, comma, angle xyz is equals to 54 degree, and yo and zo are bisectors of angle xyz and angle xzy respectively. Okay, and we have to find here is we have to find two angle. One is angle OZY and angle YOZ. So let's start the answer of this question. Let's write solution. Okay, so we can easily find the measure of this angle by applying angle sum property. We know the measure of the other two angle. One is 54, second is 62. So we can find easily the value of the angle Z. Okay, so first we'll write in triangle XYZ we have that angle X plus angle Y plus angle Z is equals to 180 degree, and this is by the linear pair, not linear pair, this is angle sum property. Angle sum property of a triangle. Okay, so we have the measure of angle X, which is 62 degree, we have the measure of angle Y, which is 54 degree, and we have to find the measure of angle Z. So that will be plus Z equals to 180 degree. So from here angle Z will be 180 degree minus this 62 plus 54 will be 116. Okay, this will be 116. So angle Z will be equals to 180 minus 116 will be 64 degree. Okay, so the answer for angle Z is 64 degree. Okay, now since in this question it says these YO and ZO, these two YO and ZO are the bisector of the angle XYZ and ZXY, that means these two angles and these two parts are equal. Okay, so if this total angle is 754, so its half will be half of 54, that is 27. Similarly, we have calculated the measure of angle Z is equals to 64. That means this angle OZY will be the half of 64, that is 32. Okay, so let's write, since YO and ZO are the bisectors of angles XYZ and angle XZY, therefore this angle which we have to find angle OZY, this angle OZY will be half of the angle Z, therefore the angle OZY will be equals to the half of angle X will be half of the angle, this one XYZ, sorry XZY, and we have calculated the measure of angle X, or you can write this angle X as angle XZY, both are same. The middle angle is the actual name of the angle, so this will be 1/2 into, and this XZY was 64, so when you divide 64 by 2 you will get 32, hence the measure of angle OZY is 32 degree. Similarly, Similarly, this half angle, this side angle OYZ will be angle OYZ will be the half of angle XYZ, angle XYZ, which will give us 1 by 2 into that angle is 54, so its half will be 27. Okay, so now we in this triangle we got the measure of two angles. This one is 27 and this one is 32. So by adding these two and subtracting from 180, you will get the measure of this one. Okay, by the angle sum property of a triangle. Okay, now in triangle OYZ, the sum of angle OZY plus angle OYZ plus angle which we have to find YOZ has to be equals to 180 degree. This is by angle sum property of angle sum property of triangle. Okay, so we have OZY here, which is 32 degree, plus angle OZYZ is 27 degree, plus angle YOZ we have to calculate. So from here angle YOZ will be equals to 180 degree minus this 27 plus 32 will be 59 degree. Okay, and the result will be 121 degree. So the value of angle YOZ is 121 degree. So that's the answer of question number 2 of exercise 6.3. Moving to the next question, we have in figure AB is parallel to DE. So it's already given that this side AB is parallel to DE, and the measure of angle BAC, angle this one BAC is equal to 35 degree, and angle CDE, this one is 53 degree, and we have to find the measure of one angle which is angle DCE. This one DCE is here. Okay, we have to find the measure of this angle while we are given the measure of other two angles. Okay, this is very simple, as it is already given these two sides are parallel, and then we'll take this AE as the transversal. So this angle BAC will be alternate interior angle to the angle CED, and they will be equal. So we will get the measure of these two angles. Then we can easily find the measure of third angle by applying the angle sum property of a triangle. Okay, so let's start is answer number 3. First we'll mention the given part. Given in the question is AB parallel to DE, and angle BAC is equals to 35 degree, and angle CDE is equals to 53 degree, and we have to find here is we have to find the value of one angle which is DCE. Okay, let's start the solution. So first we'll write, since AB is parallel to DE, since AB is parallel to DE and AE is a transversal, therefore the angle BAE will be equals to angle DEA. Angle BAE will be equals to angle DA. This is by the alternate interior angle theorem. That means these two angles are alternate angles. Okay, BAE is already given, which is 35 degree. So angle DEA is also 35 degree. So this angle is 35 degree. Now you can apply the angle sum property for the in the triangle DCDE. So apply in triangle CDE, we have Let's add the all three angle. We have the first angle is angles CDE plus angle DEC plus angle DCE, and they will be equals to 180 degree. This is by the angle sum property of triangle. This is by angle sum property of a triangle. Okay, so CD is given in the question, which is 53 degree. Angle DEC is this one, angle DEC. Angle DEC or DA are the same thing, so we can also write this DEC as DEA as DAC. So that is 35 degree, and we have angle. Okay, why I have written this DE is equals to DEC? That D is here, DEC. If you stop till here, it will be DEC, and if you move forward, it will be DEA. Okay, but this angle is same in both cases. So this is 35 degree plus angle DCE we have to find, and this is equals to 180 degree. So angle DCE will be equals to 180 degree minus, let's add these two angle, this will be 88 degree. So the measure of angle DCE will be 180 minus 88 degree, will be 92 degree. Okay, so that's the answer of question number 3 of exercise 6.3. Now moving to the next question, we have in figure 6.42 line PQ and RS are intersecting at point T. So we have two line PQ and RS, and they are intersecting at point T such that angle PRT, this one is 40 degree, and angle RPT is this one, which is 95 degree. And we have another angle which is TSQ, angle TSQ, which is here, is 75 degree. We have to find the measure of one angle which is SQT. SQT is here. Okay, so let's start its solution. Let's answer number 4. First we will write the given is two line PQ and RS, two lines PQ and RS intersecting at point T such that angle PRT is equals to 40 degree, angle RPT is equals to 95 degree, and angle TSQ is equals to 75 degree. Okay, and we have to find here is we have to find the measure of one angle which is SQT. We have to find angle SQT. Okay, so now let's start its solution. In triangle PRT, this one, angle PRT, in this triangle the measure of two angle is given, so we can easily find the measure of third angle by applying the angle sum property. Okay, so let's start. In triangle PRT we have the angle PRT plus angle RPT plus angle PTR will be equals to 180 degree. This is by angle sum property. Angle sum property is actually the theorem 6.7. Okay, so we are given the measure of both the angle PRT is 40 degree and angle RPT is 95 degree. Now we can find the angle PTR, that will be angle PTR will be equals to 180 degree. Let's add these two angles. 95 plus 40 will be 135. So this plus 40 plus 95 will become minus 135. That means the angle PTR is equals to 45 degree. Okay, so the measurement of this angle is 45 degree. So if this angle is 45, its vertically opposite angle, this one is also 45 degree. Okay, so right now angle is vertically opposite angle STQ. Angle STQ will be equals to angle PTR. Angle PTR, because they are vertically opposite angles. Okay, SQT will be equals to PTR. That means SQT is equals to 45 degree. STQ. Okay, so again we got this angle of as 45 degree. Now in triangle STQ we got the measurement of two angle. Again by applying the angle sum property we can find the third angle SQT. So let's start. Now in triangle, that triangle is STQ or QST, whatever name you can give. So in triangle TQS, the sum of the angle SQT plus angle STQ plus angle TSQ will be equals to 180 degree. Again by angle sum property of a triangle. Okay, SQT we have to calculate, STQ we have calculated here, which is 45, and TSQ is given in the question, which is 75 degree, equals to 180 degree. So from here SQT will be equals to 180 degree minus this 45 plus 75 will be 120, or angle SQT will be 180 minus 120 will give us 60 degree. So that's the answer of the question number 4 of exercise 6.3. Okay, question number 5 is in figure 4.6.43 we have PQ perpendicular on PS and PQ is parallel to SR. We are given the two angle, that is angle SQR. This angle SQR is this one is 28 degree, and angle QRT, which is the exterior angle, this one is 65 degree. Then we have to find the value of two angle with this angle X and Y, which are here. X is here and Y is here. Okay, so let's start the answer number 5. Okay, so first we'll write the given part. First we will write the given part. Given here is PQ is perpendicular on PS and PQ is parallel to SR. Also we are given the two angle SQR is equals to 28 degree and angle QRT is equals to 65 degree. Okay, and we have to find is we have to find the value of angle X and Y. Okay, so let's start the solution. Solution here is, so first what we're gonna do is we'll take this triangle SQR. In this triangle SQR, this is SQR, we are given this exterior angle as 65 degree, and by applying the exterior angle theorem, we know we are also given this angle is 28. By applying exterior angle theorem we can find the angle of value of this angle. Okay, so we'll write in triangle in triangle SQR, so we'll write in triangle SQR, exterior angle, we have exterior angle QRT will be equals to the sum of the its two interior opposite angle, which are angle SQR plus angle QSR, exterior angle QRT is given, which is 65 degree. Angle SQR is also given, which is 28 degree, and from here we can calculate the value of angle QSR. So angle QSR will be 65 degree minus 28 degree, that will be 47 degree. Okay, not 47, that will be 37 degree. Now since we got the value of this angle as 37 degree, and in the question it's given that PQ is parallel to SR, and we will consider this QS as a transversal, therefore these two angles will be alternate interior angle. Okay, so I'll write since PQ is parallel to SR and this line QS is a transversal and QS is a transversal. Okay, QS is transversal, therefore these two angle PQS will be equals to angle PQS will be equals to angle QSR, because they are alternate interior angle. They are alternate interior angle. So angle PQS will be equals to 37 degree, and PQS is given in the question as X. So we got the value of X, which is equals to 37 degree. Okay, now we can easily find the value of Y, because in triangle PQS, this triangle, we have this angle as 90 degree and we got the value of this angle as 37 degree. So by applying the angle sum property, we can easily calculate the value of angle Y. Okay, now we'll apply in triangle PQS. Okay, in this triangle, this one PQS, the sum of the angle, we have the three angle. First one is, which we have to find, which is PSQ plus angle PQS plus angle QPS will be equals to 180 degree, and this is by the angle sum property of triangle. So angle PSQ that is given as Y, which we have to calculate. Angle PQS is we have calculated, which is 37 degree here. Okay, and we have angle QPS, which is given as 90 degree, so equals to 180 degree. So from here angle Y will be equals to 180 degree minus this 90 plus 37 will be 127. So Y will be equals to 180 minus 127 will give us 35 degree. So that's the answer of Y. Okay, so we got the value of both X and Y here. Okay, that's the answer of question number 5. Now moving to the next question, we have question number 6, which is a very important question. So understand this carefully. It says in figure 6.44, the side QR of triangle PQR is produced to point S. So we have triangle this PQR. We initially have this triangle PQR, in which the side QR is produced till points S. This side QR is produced till point S here. Okay, then it say the bisector of angle PQR, this one angle PQR, the bisector of this angle Also the bisector of PRS, bisector of angle PRS, this one, when you extend them they meet at a point which is named as T. Okay, now we have to prove that the angle QTR, angle QTR is this one, QTR, this part of the angle that is in this figure, this angle is equal to the half of angle QPR, this one, that is this angle is half of this angle. That's what we have to prove here. Okay, so let's start with first writing the given part. This is answer number 6. First we'll write the given. Given here is, in triangle PQR, side QR is produced to a point S. Okay, and the bisectors of angle PQR and angle PRS meet at point T. Okay, then we have to prove this. To prove here is that the angle QTR is equals to half of the angle QPR. Okay, that's what we have to prove. So let's start its proof now. This is very important question, so listen it carefully. So for this triangle PQR, we have extended it, the line QR, till point S. So we have got this exterior angle which is this one, and we know from the exterior angle theorem that the exterior angle is equals to the sum of the two interior opposite angle. Okay, so we'll write, in triangle PQR, in triangle PQR we have the exterior angle, that exterior angle is angle PRS. Angle PRS will be equals to angle P and angle Q. P is actually angle QPR plus angle PQR. Okay, the exterior angle PRS, this angle is sum of the angle, these two angles. Okay, that's what I have written here. Exterior angle PRS equals to plus of, is equals to sum of angle QPR and angle PQR. Okay, so if we divide or if we multiply the equation by 1/2 on both sides, so let's write, on multiplying the above equation by 1/2 on both sides, we get what we're gonna get is, that is half of exterior angle PRS equals to half of angle QPR and half of angle PQR. The half of angle PRS, from the figure you can see the half of angle this PRS is TRS, so we can write at the place of this angle TRS. Okay, and at the place of angle half QPR we keep it like this, and half of angle QPR, but we can write this angle PQR, half of angle PQR. PQR is this one, is half is, let's write this one TQR. We can write this as half of this as angle TQR. Okay, so that's our, let's name it equation number 1. Okay, what we have done is we can rewrite this angle, half of angle exterior angle PRS as TRS and half of angle PQR as angle TQR, while keeping this half of angle PQR as it is. Okay, now similarly we'll apply this exterior angle theorem in for now the triangle TQR. We have this triangle TQR. Again, its one side is produced till point S, so the sum of this angle will be equals to the sum of this interior opposite angle. Okay, in similar we'll write now in triangle, that triangle now is TQR. Now in triangle TQR we have exterior angle. Here the exterior angle is angle TRS. Exterior angle is angle TRS is equals to its sum of the two its opposite angle, that is angle QTR angle. We can write this as TQR and QTR. TQR and QTR. TQR plus angle QTR. Okay, so we already have this exterior angle TRS. We can write this only as TRS is equals to TQR plus QTR. TQR and angle TQR. This angle TQR let's name it equation number 2. Okay, now on comparing equation 1 and equation 2, in both equation you will find that we have the TRS equals to this one and here the TRS equals to this one. So we'll write from comparing equation 1 and 2, or you can easily write from equation 1 and 2 we get, since both are equals to TRS, so we'll write these two are also equal. Okay, so we'll write them equal, that is from equation 1 we have half of angle QPR plus angle TQR equals to angle TQR plus angle QTR. Okay, now on both sides we have TQR. This can be calculated out. What remain will be half angle QPR equals to angle QTR. These two will be cancelled because if you move this part onto the left hand side it will be minus, so this is also already plus, so plus 1 will be 0. Or if you shift this one on this side, if this is of plus on this side, on right hand side will become minus, so plus TQR and minus TQR will result into 0. That means we can directly eliminate them. Okay, by writing this remaining terms equal. So half of angle PQR is equals to angle TQR, and this is what we are asked to prove here, half that TQR is equals to half of PQR. This TQR is equals to half of angle PQR. Okay, this is what we were asked to prove here. Okay, I hope you understood how we have done this. We have simply used the exterior angle theorem 2 times in this question. Okay, and we got the required result. So this is how we can complete the question number 6. So I hope you understood all the question. So you will, in order to understand this question better, what you have to do is practice all this question at least 2-3 times by yourself, then only then you will be able to understand it better. Okay, so with this we have concluded the exercise 6.3 and also the chapter 6. So thanks for joining here. That's all for now.